Good day. Today I'm going to discuss about magnesium. Magnesium is a silvery white metal of the valent alkaline earth group number 12 in the periodic table of elements. So it is a silvery white metal that ignites easily in air and burns up with a bright light. So, once magnesium starts to burn, it is almost impossible to extinguish because it reacts exothermically with oxygen, nitrogen, and water. So, it burns with bright light and it made an ideal incendiary agent, and in some air raids during World War II, as many as half million 2 kg magnesium bombs would be scattered over the city in space of an hour. So the result was massive conflagration and firestorm. So bulk magnesium metal is not easily ignited. So this had to be done with thermite reaction as the heart thermite reaction and the heart of the bomb. So the thermite reaction between aluminum powder and iron oxide releases more than enough heat to cause magnesium casing the bomb to burn perfectly. So magnesium is one-third less dense than aluminum. So it improves the mechanical fabrication and welding characteristic of aluminum when used as alloying agent. So these alloys are useful in airplane and car construction. Magnesium is used in product that benefits from being lightweight such as car seats, luggage, laptop, cameras, power tools. It is also added to molten iron steel to remove sulfur. So as magnesium ignites easily in air, it burns with a bright light and is used in flares and fireworks and sparkles. So magnesium sulfate is sometimes used as mordant for dyes. Magnesium hydroxide is added to plastic to make them fire retardant. So magnesium oxide is used to make heat resistant bricks and fireplaces and furnace. So it is also added to cattle feed and fertilizer. So magnesium hydroxide of milk of magnesia sulfate is Epsom salts, and chloride and citrate are also used in medicine. Now let's move on to the biological role of the magnesium. So magnesium is an essential element in both plant and animal life. So chlorophyll is a chemical that allows plants to capture sunlight and photosynthesis to take place. So chlorophyll is the magnesium-centered chlorophyll complex. Without magnesium, photosynthesis could not take place and life as we know would not be exist. So in humans, magnesium is essential to the working hundreds of enzymes. So humans take about 250 to 350 milligrams of magnesium each day. So which we are we each store about we each store about 20 grams of our bodies, mainly in the bones. Now we're going to talk about the natural abundance of magnesium. So magnesium is the eighth most abundant element in earth crust, but does not occur uncombined in nature. So it is found in the large deposits in minerals such as magnesite and dolomite. The sea contains trillions of tons of magnesium, and it is the source of much 850,000 tons now produced each year. So it is prepared by reducing magnesium oxide with silicon or by the electrolysis of molten magnesium chloride. So we have here 10 kinds of magnesium. So one is these are magnesium citrate, magnesium oxide, magnesium chloride, magnesium lactate, magnesium malate, magnesium taurate, magnesium L-threonate, magnesium sulfate, magnesium glycinate, and magnesium orotate. First is the magnesium citrate. So magnesium citrate is a form of magnesium that is bound with citric acid. So this acid is found naturally in citrus fruits and gives them their tart, sour flavor. So artificially produce citric acid and used as preservative and enhancer of the food industry. So number two is the magnesium oxide. Magnesium oxide is a salt that combines magnesium and oxygen. It is naturally forms a white powdery substance that may solve in powder or capsule form. So it is also the main active ingredient in milk of magnesia and popular over-the-counter medication for constipation relief. So the third one is the magnesium chloride. Magnesium chloride is a magnesium salt that includes chlorine, an unstable element that binds well with other elements including sodium and magnesium to form salt. So it is absorbed in digestive tract, making a great multi-purpose supplement. You can use it to treat low magnesium levels, heartburn, and constipation. The fourth one is the magnesium lactate. So magnesium lactate is the salt form when magnesium binds with lactic acid. So this acid is not produced by your muscle or your body cells, but it is manufactured for use as preservative and flavoring agent. So indeed, magnesium lactate is utilized as a food additive to regulate acidity and fortify foods and beverages. So less popular in over-the-counter dietary supplement. So number 5 is the magnesium malate. So magnesium malate includes malic acid, which occurs naturally in foods like fruits and wine. So this acid has a sour taste and is often used as food additive to enhance flavor and or add acidity. So the magnesium taurate contains amino acid and taurine. So research suggests that adequate intakes of taurine magnesium play the big role of regulating blood sugar. Thus is particularly form many promote healthy blood sugar levels. So number 7 is the magnesium L-threonate. So magnesium L-threonate is the salt formed from mixing magnesium and thionic acid and water soluble substance derived from the metabolic breakdown of vitamin C. Number 8 is the magnesium sulfate. So magnesium sulfate is formed by combining magnesium, sulfur, and oxygen. So it is commonly referred as the Epsom salt. So it's white with a texture similar to that of table salt. So it can be consumed as treatment for constipation, but it is unpleasant to taste, leads many people to choose alternative form for digestive support. Number 9 is the magnesium glycinate. So magnesium glycinate is a form from elemental magnesium and amino acid glycine. So your body employs this amino acid in protein construction. It is also occur in many protein-rich foods such as fish, meat, dairy, and legumes. So the last one is the magnesium orotate. So orotate includes orotic acid, a natural substance involved in your body construction of genetic material including DNA. It is easily absorbed in and doesn't have a strong laxative effects characteristics of any forms. So now we're done with magnesium. So let's tackle about the magnesium alloy. So magnesium alloy are well known for being the lightest structural alloy. So these are made of magnesium, the lightest structural metal mixed with other metal elements to improve the physical properties. So these elements include manganese, aluminum, zinc, silicon, copper, zirconium, and rare earth metals. So some magnesium is favorable properties include low specific gravity and weight high strength to weight ratio. So as a result, the material lends itself to range of automotive, aerospace, industrial, electronic, biomedical, and commercial applications. So the types and designation of the magnesium alloy. So magnesium alloy can be categorized into groups, the cast alloy and the root alloy. So cast alloy is are basically made by pouring the molten liquid metal into a mold within each solidifies into the required shape. So common cast alloy of magnesium consists of different amounts, so but not exceeding 10% of aluminum, manganese, and zinc as a principal alloying elements. So other alloying elements have been recently used as well as mostly to enhance the chip resistance, such as zirconium and rare earth metals. So besides mechanical properties of cast alloy can augmented by heat treatments. So the other one is the root alloy. So in other hand, are alloys subjected to mechanical working, so such as forging, extrusion, and rolling operation to reach the desired shape. So aluminum and manganese, zinc are also the main alloying elements. So roth alloys of magnesium are sorted into heat treatable and non-treatable alloys. Now let's talk about the physical properties of magnesium alloys. So magnesium alloys are the materials of interest mostly due to their high strength to weight ratios, exceptional machinability, and low cost. So they have a low specific gravity of 1.74 gram per centimeter cube and the relatively low Young's modulus 42 GPa compared to the common alloys such as aluminum or steel alloys. So they have suffered, however, the brittleness and poor formability at room temperature. So their formability increase with increasing temperature but requires high energy. So magnesium alloys are the third most popular non-ferrous casting materials. So the physical properties of alloy change based on their chemical composition. So adding different alloying elements would result to different properties and different conditions. So these are the aluminum. Aluminum improves the strength, hardness, and ductility, facilitating and facilitating the alloy casting process. So number two is the zinc, which is increase the room temperature, strength, fluidity in casting, and corrosion resistance. So number three is the manganese. Manganese helps to increase the resistance of AM and Cg alloy to saltwater corrosion by forming intermetallic compounds with iron-like metals to be removed during melting. So the rare earth metals help increase strength and resistance to high temperature, creep with corrosion, and decrease porosity and dwell cracking. So zirconium is a strong grain refiner when added to alloys containing zinc and rare earth metals. Beryllium helped to decrease surface oxidation during the casting and welding. So the last one is the calcium, increased brain refinement, which help controlling the metallurgy of the alloys. So now let's move on to the application of magnesium alloys. So magnesium alloys cover a wide area of application, some from automotive to aerospace, application to electronic and biomedical uses. So the structural application in magnesium alloy is in automotive, aerospace, industrial, commercial application, are example of structural application. So the advantage of magnesium alloy is to be used such as application of their lightweight, high strength to weight ratio, castability, machinability, and rate damping. So in automotive, the the rule of magnesium alloy, it can be, or the material that is from magnesium alloy are like the support brackets for brakes and clutch in automotive, housing for transmission. In aerospace is the landing wheels, helicopter rotor fitting, gearbox housing. And in industrial, high speed operating machinery such as textile machines, and in commercial, luggage, hand tools, computer housing, and ladders. So those are the materials that are made of magnesium alloy. So these are in electronics application, include electronic packaging, hard drive arms, cell phones, portable media device housing. Magnesium alloy are being used instead of plastic due to their lightweight, strength, and durability. So they are also relatively better for heat dissipation and protection against electromagnet and radio frequency interference. So in medical application, so portable medical equipment, wheelchair, and that require light material to make good use of magnesium alloy. Also, cardiovascular stents and orthopedic, ortho, orthop, orthopedic orthopedic device are potential application. So that's all about my report about magnesium and magnesium alloy. I hope you have learned something from my report and have a great day. Thank you.